Today we'll be taking a look at integration by parts. Real quick, let's go and take a look at where the formula comes from. As you can see, we take the product rule and then we take the derivative of both sides, and that's how we get the corresponding integration rule. Some people use f of x and u, or g prime of x and dv, but either way, you get u times v minus the integral of v du. The whole point is to simplify it down into an integral we know how to integrate. So taking a look at this, I know I can break down ln of x into 1 over x, and that might make it easier to integrate. So I'll make u ln of x, and then dv the 8x squared. Now I'll go ahead and take du, which is 1 over x, and then I'll take the integral, which is v, which is 8x cubed over 3. Again, that 8x cubed over 3 comes from that 8x squared. So now what we'll do is we'll go ahead and just plug it into the equation that we already have. So it becomes the ln of x times 8x cubed over 3 minus the integral of 8x cubed over 3 times 1 over x dx. Now as you can see, the x's cancel out and we are left with an x squared on top, giving us the natural log of x times 8x cubed over 3 minus the integral of 8x squared over 3 dx. And so now we can evaluate that as we would any normal integral. So again, we have the ln of 8x cubed over 3. And I am going to pull the 8/3 out of the integral because it is a constant. So we're going to have 8/3 times the integral of x squared dx. Now we can just go ahead and integrate that, in which we get natural log of x times 8x cubed over 3 minus 8/3 times x cubed over 3 plus a constant c. Now rewritten, we just get the natural log of 8x cubed over 3 minus 8x cubed over 9 plus c. We can take it one step further for simplifying, but it's really not necessary. We get 9 natural log of x times 8x cubed minus 24x cubed all over 27 plus c. Alright, that's the solution to the first one. Now let's take a look at another example. So looking at this next one, I can see that if I take the derivative of 7x, then we can break that down into a constant. So I'm going to go ahead and make u be equal to 7x and dv equal to cosine of 2x. So now when I take du, I get 7 dx, and when I take the integral of the cosine of 2x, we actually are going to have to use u substitution. So we'll make the u equal to 2x, and the du equal to 2 dx, and then we'll divide by 2 on both sides. So we get half du is equal to dx. And now we can just go ahead and integrate. So we go ahead and get half of the integral of cosine, forgot the integral, of u du. And so now we can go ahead and get 1/2 times the sine of 2x plus c. And we can see that the 2x just comes from replacing it with a u. So now we know our v, and we'll go ahead and write that. V is equal to 1/2 times the sine of 2x. And we're going to disregard the c. And now we can go ahead and plug everything into our integration by parts formula. And so we get 7x times sine of 2x all over 2 minus the integral of 7 sine of 2x all over 2 dx. And now when we simplify further, we get 7x times the sine of 2x all over 2 minus 7/2 times the integral of sine of 2x dx. And what you'll notice is that we cannot do this integral without u substitution. So we'll set u equal to 2x, making du equal to 2 dx. And then when we solve for that, we get 1/2 du is equal to dx. So now we will go ahead and rewrite this whole thing out. So we get 7x times the sine of 2x all over 2 minus, and we'll go ahead and combine the 1/2 and the 7/2 to get 7 over 4 times the integral of sine of u du. And so now we can evaluate this integral just like any other. And then rewriting this out, we get 7x times the sine of 2x over 2 minus 7/4 times the negative cosine of 2x plus c. Simplifying even further, we get 7x times the sine of 2x all over 2 plus 7 over 4 times the cosine of 2x plus c. Now for the next one, you'll notice that this example just has one function. And so what we'll do is we'll make arcsine of x equal to u. So dv is equal to dx. So v is equal to x. And then the derivative of arcsine of x is equal to 1 over the square root of 1 minus x squared dx. So now we can go ahead and plug all of that into our formula, and what we end up getting is x arcsine of x minus the integral of x over the square root of 1 minus x squared dx. And so now what you'll notice is that we're going to have to use u substitution to evaluate that integral. So we'll set u equal to 1 minus x squared. So du is equal to negative 2x dx. Solving for du, we get negative 1/2 du over x is equal to dx. We're going to go ahead and get x arcsine of x minus, actually it's going to be a plus because of that du, the integral of x over the square root of u times du over dx. And we're also going to go ahead and pull that 1/2 out as well. We're going to pull that out front of the integral, so it's 1/2. So we're going to go ahead and cancel out the x's, and then we're going to go ahead and rewrite this, and we're going to go ahead and get that it's equal to x arcsine of x plus 1/2 times the integral of 1 over the square root of u du. And now we can go ahead and solve for this integral just like we would for any other. We're going to go ahead and get x arcsine of x plus 1/2 times 2 square root of u plus c. And we can note that that 1/2 and that 2 will cancel, and then rewriting, we're going to go ahead and get x arc sine of x plus the square root, and then we'll go ahead and plug in the u, 1 minus x squared plus c. Alright, and that is our final answer. Thank you for watching. I hope you learned something from this, and if you liked it, please leave a thumbs up.